I think screen, you all are visible to my screen, right? Yes, this is a US master window. Here in this, we can do drone mapping and also is close range 3D mapping. It's for 3D model buildings. I will explain area mapping in this one. In this, we have to give coordinate system, or else there will be a geotag images. It will automatically takes from the image. I will show that also. Yeah, we can find out here based on APSG code country. We can type countries and find out the codes, and also selecting images. Or else, if we know that coordinate system, we can go to here and directly we can keep that coordinate system. So at present, I am selecting the images, one single image. You know, it's see here, it's directly will come the coordinate system. Whatever the images having geo tags, automatically it will come here. We have to select this and okay. Next, apply. Okay. Next, we have to add the images, whatever the drone collected from survey. So there are two options. We can add directly files, or also we can give one directory, whatever adding images containing. And in this, it automatically reads camera file, and it automatically reads GNS and IMU exterior orientation data from the images, and the terrain data. What is the mean terrain height? Also, it will take automatically. Next, you can see here we have not given manually anything here. X, Y, Z, omega, pi, kappa, GNS data. It automatically read from the images and it have assigned to the each image. There are 218 images here. For 218 images, it automatically given X, Y, Z, omega, pi, kappa. If we have GCPs, we can add here in GCPs. At present, this data has no GCP. And also camera file also, you can see here automatically it has taken from the images, focal length, pixel size, width and height, and also PPX and PPY. Next, we have to generate the strips. It is also an automate, no need to do manually. And once we are done with project, we have to give one folder for the project file and the one name. Save. Here you can see the images with whatever the orange color it is coming, it's images, and the blue line, it is the flying strips, how drone is flied. Once it completes, we will get the project like this. You can see this one. Next, georeferencing part will be there in this. GCPs also I will add once. Okay. Yeah, here GCP is also I have added for the sum of there. Here you can see once project completed, you can view these GCPs also. There are multiple steps are there in this before and after also we can do the type points. There are some steps, manual steps also there, and also the automate batch wise. You can see my cursor where it is. Here we can do the project preparation already we have done, and then GCP measurement, and this is the part is total completely automate process. After GCP measurement we can give automate process for these all steps, but I am showing only manual way. These once completion of project setup, we have to generate type points by keeping based on the density and based on the images height. We can give highest, high, medium, and also low density. Future density is this normal density. And image radiometric also it is automatic. It will adjustment the colors also in this while creating type points only. Then we have to keep start this, so it will create type points. You can see here these are red color, green color points are the type points. The green points are the type points, and these red color will be the GCP points. So once completion of these type points automatically, we have to measure GCPs from this. And in this software, it is one good option in this is we can measure type points also. It is a unique one in our software. The type point generation after type point generation, what wherever the type point is not good, we can manually measure the type point also. I will show this once. These are the GCPs. Oh, all can see here one yellow color square one, right? These are measured while doing survey, drone survey. They have measured, pasted the one yellow color paper, and they are kept in center of this. We have to measure this one. And once completion of one or two GCPs, we can do automate also for these GCPs. Like this, we have to measure all the GCPs. We already measured in this. You can see here. Next, we have do orientation. Nothing but it called as aerial triangulation for this. Based on type points and GCP measurements, image adjustment and georeferencing block adjustment will be done automatically from this option. After that, um, we have to do radiometric also. It in this radiometric, it will do image color balancing. Nothing but it is color balancing. It will also do based on the parallel overlap of images, and it will do the correct way of radiometric. Next, in this we will create DSM and DTM. I hope all can see this window. This is a DSM part. This is not an image. This is a DSM. Already I have generated. Based on this surface generation, we have to click surface generation. Strategy, we have to keep new strategy. In this, we have five types are there. Terrain only DTM, digital terrain model, and surface DSM. And for this SGM 2.5D, it's for these three is for true orthophoto. We can generate true orthophoto from these three options. The classic orthophoto from these two options. Here, extraction level, there are four types: low, medium, and high and highest. Four types of point cloud we can extract from the images. After generating this DSM and DTM, we will go to orthophoto generation. In this also we have to create one strategy, like we want a classic orthophoto, true orthophoto, or quick orthophoto, and orthophoto from point cloud. And the pixel size will be based on the client, whatever they will ask, or else we can keep automatic based on the input. It will keep one value, and we will get the output. So these are the four outputs from the drone survey images we can take out: orthophoto, DSM, and DTM. And once we get DSM or DTM, and another unique thing in our software is we can edit point cloud also here. This is a unique one in our software, Trimble software. You can see here I have selected some of the points, whatever here. Start point cloud, load into the editor. Here we can generate contours. And this is a fully stereo method. We can see 3D also in this. We can edit completely in 3D level. I'm opening that also, but hope you can't see here 3D, but you can visualize. Hope you all are seeing two buildings here. It came one. This now 3D is available for this. Based on this, we can generate contours. Break lines also we can capture in 3D. After all editing, we can use the same thing in the orthophoto generation. So these the output. Three outputs will be coming in this US master: true orthophoto, classic orthophoto, DSM, and DTM. Have any doubts on this process or any output? Any doubts? Krunal sir. Okay, so that's the US master capabilities. So I am giving to Sivaram sir again back.
What is TriPoint?
Tie points. It's based on the images. It will take some points, same locations from each image. While block adjustment and georeferencing based on the tie points, it will stitch us like a mosaic. For mosaicing purpose, we need the tie points for georeferencing. After collecting from drone survey, images will overlap on all at location 0. Based on the tie points and GCP measurement, it will be sitting in a correct coordinate system, and we will get orthophoto. I will show that once you will get an idea. See here the sentence: acquire tie points and build the image network. I'm showing one tie point. See here. Automatically this software recognizing this tie point, automate tie point. See, location will be the same. So it will take these locations and it will be tie together and do block adjustment based on these tie points and also measure the GCPs. Any other, sir?
No, sir.
Thank you. Sivaram, sir.
Thanks, Ramesh. Hope that tie point answer is clear. Basically, when you fly a drone, you will be having an overlap of 70 to 80%. And this overlap, the points in the overlap, which will be used to actually join all these multiple images and remove the overlap, will be the tie points for that, for adjustment and all. Okay, is that fine? Yeah. So now what I'll do is I'll show you the eCognition product capability, and I've shared my screen. Yeah. Basically, this is the user interface of Trimble eCognition software. If you look at why Trimble eCognition is different from other image processing software, is basically it uses object-based image analysis. So there are two concepts. One is pixel-based image analysis, other is object-based analysis. Now, pixel-based, you know that it will be taking the characteristics of pixel and doing the classification and other statistical operation you can do, and you can analyze the image. But in case of object-based image analysis, what happens is the object is taken, like its shape and the nearby pixel values, its texture, and whatever characteristics are available. I'll give you an example of a water body. There are different types of water body, like a river could be a water body, a lake could be a water body, small pond could be a water body, and a large sea is a water body. So when you do an object analysis, the object analysis can be done for a river, saying that the length of the polygon or the water body is very high. Length to width ratio is very high when we do a when we take river as a polygon. And when we look at a pond or a lake, uh, the shape index, which is basically a circular shape index, will be very high in case of a lake and pond. And the other characteristics will be, it will be surrounded by the water, surrounded by the land, sorry, surrounded by the land. And in case of C, it will have your same NDWI value, but the size of the water body will be very large. And suppose there's a land feature inside the sea, then you can classify that land feature also as an island, since it is surrounded by water. So this is the concept of object-based analysis. This is the screen. So to start with, what eCognition does is you can actually fuse data using eCognition. What I have opened is you can see my screen. This is a basic satellite imagery with 4 bands, which has RGB and infrared. So this is a 4-band imagery. You can also load, in case you have vector data. I am just loading one shape file which I have. If you look at it, simple points which are there. So you can also load your vector data. If you have point cloud data, you can load that point cloud data. And you can fuse all this data for your analysis. And on the left hand side, it basically gives you the option to see the layers, switch on, switch off the layers. So you can play around the layers, and you can move to your grayscale image also. And basically here you are able to do your equalization. You can do a linear equalization or a histogram equalization. This is the part. The main heart of eCognition are two things. One is a process tree and other is a feature view, where we can take the features of your image and do the analysis. So to start with, what I'll do is I'll simply start. Process is the set of algorithm. Process tree is set of algorithm which you will actually write so that these algorithms will be executed. So I am creating an algorithm where it's a parent algorithm where child algorithms will be executed. So I say do, and then I add new process. Sorry, I'll add a new child process, and it gives you an option. You are able to see my window of the edit process. So basically here you can see all the list of algorithm. I'll just take 5 minutes to explain this. You have segmentation. It supports all type of segmentation, like chessboard segmentation. What it does is chessboard segmentation, you specify the number of pixel. Suppose I am taking chessboard segmentation and I say key create a chessboard of 100 by 100 pixel on the image, and I execute that. So if you look at this, has created this type of segmentation. And again, I'll open the process. This has quad tree based segmentation. Quad tree chessboard is it simply dividing the number of pixels we are specifying and segmenting it. Quad tree will be dividing it into 4 parts and till you get the homogeneity. Suppose you divide a square into 4 parts, check the homogeneity for 4 parts. If they are homogeneous, you leave it. Otherwise, you again divide each part again into 4 parts. Other is contrast split. Contrast split, you specify what are the values, uh, maximum and minimum threshold based on which segmentation will happen. And similarly, we have standard deviation. Based on standard deviation, if you have a vector layer available, you can use the vector layer also. Suppose you have some kind of building footprint, you can put it on an image and do the segmentation. You can do spectral difference, multi-threshold, superpixel, contrast filter, and watershed. All these segmentations, basically, if you look at, they all have simple parameters which you need to specify, like at which domain. Basically, it could be pixel level or it could be object level, and what are the layers it will be using to segment, how many pixel, and all. So I'll do a multi-resolution segmentation. Basically, I am using all 4 layers and shape 0.1 and 0.5. Default, I am leaving it. Any algorithm on top of it, it will give the description. Like this, what it does is it does the optimization which locally minimizes the average heterogeneity. So I am executing this. So it is creating some objects by doing multi-resolution segmentation. Can you see it? It has created some objects. So now what I'll do is I will show you feature view. Feature view is basically the layer related statistics. Like there are image layer, you can have the mean of all the layers, you can have mode, then there's pixel base, like what is the border contrast, what is the circular means, what is the maximum value, what is, all these values can be used for your classification and segmentation. This could be scene based, quantile, which quantile, suppose you want to actually ignore 95% of the quantile and only work on some 5% of the data part, which you see are important, skewness, standard deviation, so that if there are four layers, you can check what is the standard deviation within the layers and within the objects, color transformation, and again there is geometry. Geometry based on polygon, what is the area, what is the length of the longest sides, number of edges. So all these parameters which you are seeing, these can be actually used to do segmentation, classification. There are machine learning programs which are built which you can use this data. Extent, again, area, border length, shape. So I'll just show you some examples. It could be about position and all. What I am doing is I am selecting these features. Like I want to see the mean of layer 1, layer 2, layer 3, and layer 4. Also, what I want to do is I want to see the geometry. I want to see whether the shape is rectangular, roundness, or elliptic. And extent, I want to see the area. So basically, if you look at any object I select, it gives. I am clicking in the water body, so I am getting the different values of all the four layers in the water body, and the also I am getting the mean values of all these four layers. Also, I am getting the number of pixel, the area of the extent, and I am also getting the fitness of this thing. So now what I'll do is I'll show you a simple classification on this image. I'll define classes. For simplicity's sake, I'll define 3 or 4 classes. I'll say water. I can give blue color and I'll keep it. Then I'll keep it as land and I'll keep it as, and I'll keep it as building, and I am keeping this color. So I have defined these classes, and what I'll do is I'll select these classes manually because this is simple this thing. I say select samples. I am selecting water samples. Since I know this is a water body, I'll select these samples. And then I am selecting land. You can do much more refined, number of classes can be defined more. You can actually more minutely select your samples. And I am defining this areas as buildings. After my sample selection, I am going to run a simple supervised classification. I go to process and I search for supervised classification. I have selected supervised classification. Now I am in supervised classification. I am training my model. I name my model as model 1. I define it as double or float, and I use samples to train. And my features is I am actually selecting the mean of all these layers, which is used for training to identify these classes. And as I said earlier, this supports some of the machine learning algorithms like Bayes classifier, K nearest neighbors, support vector machine, decision tree, and random trees. First, what I'll do is I'll run a support vector machine, and I keep it linear 2. And one change I do is domain. Since I have already created objects using my segmentation, I select object on top of object I do, and I execute it, and the model gets trained. It is getting trained very fast. Now what I do is I copy this and I paste the same process. Now from train I move to apply, and I don't do anything. The whole algorithm remains same. I don't change any parameter. I just change the parameter from train to apply, and I execute the model. And now the trained model has been applied with SVM. Now for seeing this, what I'll do is here the samples are being shown. I'm going to see the classes. Hope you are able to see the classification. All this has been classified as water body. This has been classified. This were some vegetation and ground was there. And this area since I have selected it, it has classified this. Now, since there are many objects, I want to merge it. What I'll do is I'll add a process which says that merge region, and by class I say I class, and I execute this. If you look at now, it has merged this. Now we want to find the area of the water body which is there. There's a lake or a pond. So what I do is I go to add new process. I select a process called compute statistics. This can be used to compute different statistical variables. I define area underscore water, and this is double, and the operation I want to define is sum. I want to do a sum of all the objects. Feature I use is here in the geometry, in the extent, I choose area, and I want area to be in acres. We can select acres and kilometers, hectometers. So I am selecting acres, and for water I am selecting water body, and I click OK, and I execute this. If you look at below, here I get the water. Water in this image is 63.18 acres. So this is the segmentation and supervised classification. Now, if you look at in the water body, there's some misclassification which has happened. Now, what I want to do is I might say that, okay, support vector machine has not done proper work. What I can do is I can change my model from SVM to K nearest neighbor. I move to K nearest neighbor. I execute it. Basically, since I'm running this segmentation again, I've run the segmentation again, and now what I am doing is since I have changed it to train KNN, object level normalize model 2. I think there's some error which has occurred because I have merged the objects and all. So this my idea was to show that all these segmentation data can be used to test all these machine learning algorithms which are there. So this is one thing which I wanted to show in terms of segmentation and classification. And similarly, this is the menu where you have workspace, and you can open and close projects. You can load image files, and this will actually provide you to maintain your entire project, entire data you are working on. So what I'll do is I'll close this project. I'm not doing any changes. I'll open another project. Basically, this is on doing a tree count delineation and the count of number of trees in a forest area. So basically, if you look at, as I said, told you earlier, I have taken this 4-band imagery, blue, green, red, near infrared, and I have also taken a point cloud data, and I have DTM and DSM. So if you look at, this is my point cloud data, which is there. So I am fusing all this data to actually identify this thing. And what I have done is I have already written my rule set, basically rule set, and I have defined some of the important parameters I require, like the area, number of pixel, trees, minimum elevation, and all. So I'll quickly take you through this demo. What I am doing is basically this is for the demo part. I'm resetting the project and settings. The first thing we do is wherever there is no data value, we are giving one -99 so that our calculations will be done accordingly. We use a feature called rasterize point cloud to actually rasterize DTM. Basically, what I am doing is I am taking DTM, the Z coordinate, to be minimum, because what I wanted to do is I wanted to take out the height of the tree by using DSM minus DTM. So I have rasterized DTM, and the Z coordinate I have defined as its minimum. I am executing this, and I am taking the DSM layer, and same way DSM layer I am taking the surface model to be highest, Z coordinate as maximum, and I am storing this in DSM process. I execute this algorithm, same rasterize point cloud I am using. And what I am doing is there is some gap in the data which is there. So I am filling this gap using a morphology algorithm which is pixel filter 2D, which will use morphology. You have an option of filter Gaussian, mean, median, bilateral, morphology convolution, and it will dilate and it will fill the data. And I am using multi-threshold. Wherever I feel that the object size is less than 1 meter, I am not classifying it. I am keeping it as unclassified, and I execute this fill DTM layer. Just filling that. Then similar thing I am doing for DSM layers. And again, here also I am unclassifying anything which is below 1 meter. And if you look at, you can see, I am calculating normalized DSM, which is basically a built-in algorithm, NDSM layer calculation, which basically takes your DSM layer and DTM layer. NDSM comes as an output, which is nothing but DSM minus DTM. So I am executing this process. And I am creating elevated objects. So minimum elevation I am taking as greater than 1 meter, and I am taking minimum 500 pixel area mapping unit, and I am doing a multi-threshold segmentation, which says that anything which is greater than minimum value, less than minimum value, classify as unclassified, otherwise put it in a temporary file. So I run this thing, and then I am doing the forest cover. Forest cover, basically, first what I am doing, I am calculating NDVI. NDVI calculation is very easy. You have to select the algorithm index layer calculation. In the index layer calculation, in the index, you have the option of selecting NDVI, NDWI, NDSI, NDBI. Based on the data, if it is a multispectral data, you can actually calculate all this value. I am doing NDVI. I am specifying the layer. My red layer I have defined as this red layer, and near infrared NIR, and the output is NDVI. So I am defining NDVI layer, and what I am doing is less than 0.2. I am anything which is less than 0.2, I am classifying as temporary, otherwise as tree. And I am also creating a border for greater than 0.25, and then temporary unclassified. I'm running this. This has classified the forest. And the last step I am doing is I am using a watershed segmentation. This is one of the available segmentation technique. I am using it on NDSM layer and 8 connected neighborhood and the seed. Basically, I am defining the seed for the watershed. So I wanted to tell you the eCognition comes with a soft copy of the user manual, and there are YouTube videos on eCognition channel which you can use, and there are sample data sets also available to try this analysis. So I'll run this. So basically it has delineated the tree crowns. And last thing what I'll do is I'll generate the tree centers, and I'll grow the crown circles. So if you look at this rule set, what it has done is it has actually given me the count of the trees by classifying the forest cover. I have used greater than 1 meter and size which is greater than 500 pixel to classify the forest cover. And I have created a buffer, and I have created the centroid of it so that I can count the number of trees which are available. So this is from my side. Any questions?
Sir, what is point cloud data?
Point cloud data will be your LiDAR data which you will be collecting. Or you can also create point cloud data from drone data. Basically, LiDAR, you understand LiDAR technology, na? Basically, there will be a LiDAR sensor which will be emitting the light rays and receiving it, and based on the time part of it, this data will be collected as point cloud. And this point cloud data would be used to measure the distance, identify 3D objects and all. Similarly, based on the optical cameras in the drone, since there is an overlap, there will be uh, point clouds can be created from that. So it has a format of LAS, which is there.
Thank you, sir.
Yeah. Acha, okay. Okay. Like this, actually, I just included because now the one is satellite imagery is now lot of data is available freely from NRSC, and Sentinel data is there. You can do analysis, and this is slightly higher in terms of application and usage. LiDAR analysis, tree counting, and all. Yeah.
No, sir.
If anything is there, you can write to Bhaskar. Huh? We'll be happy to answer any questions which are there. Yeah. Because there, I didn't actually show, there is a CNN, built-in CNN algorithms also are there, convolutional neural network algorithms, which does take time for processing data, training, samples, creation, training takes time. So they are also built in eCognitions. Okay, okay. Yeah. Okay. 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 Oh, okay. Yeah. Yeah. These are all built in. You need to have some kind of basic domain knowledge, and you should know the steps uh,
Sir,
on how you will be processing. Yeah.
sir, I have a question. Sir,
Yeah.
is it necessary to operate on multispectral data?
No. You can use simple RGB data or a grayscale image also. Hmm. It depends on the output you are looking at. Suppose you are looking at simple water or a forest or an urban related classification, your RGB data should be sufficient. But if you are looking for agriculture related application, then you might require multispectral or hyperspectral data and all.
Okay, sir.
Yeah. Thank you. Yeah. 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 Mm. Yeah. Sure. Yeah. Thank you, Pranal sir. Thank you, students. Absolutely.
Yes, sir. Uh, am I visible?
Yeah.
Thank you, Mr. Sivaram sir, and Mr. Bhaskar sir, and Mr. Ramesh sir, and also Telecare Private Limited for spending your valuable time. We are happy to learn e-cognition software. This is all new for us, and US Master. It will be fruitful for us in future. Thank you so much, sir.
Thank,
Yeah.
Thank you.
Thank you very much. Yeah.
Okay, sir. Thanks for your time. Thanks a lot. Thanks to everyone. Thank you.
Thank you. Bye.